Today's topic is compositions of transformations, and you can use the date of May 6th. Our note packet has 4 pages. So let's start with a definition of composition. We've actually done this in homeworks past, you just didn't know that you were doing it. What we're doing is taking a pre-image and we're performing one transformation on it, and then we're building on it with another transformation. So the end result is called a composition. When you produce your first image and you're ready to do the second image, we always build upon the prime. So we never go back to the original points. We just keep building on to the one previous. When a transformation or a composition is provided in notation, the order that you perform the transformations does matter. So if you go out of order, you're going to produce an incorrect image. This diagram is a picture of a composition. The red triangle is my pre-image, and I know that because there is no prime notation. What I'm doing the first time is reflecting in this blue line M to produce the light blue triangle A prime, B prime, C prime. And then I'm building onto this prime image and reflecting it over line N to produce the yellow triangle A double prime, B double prime, and C double prime. Once you've plotted everything, you can look at this and realize that I could have gone from the red triangle to the yellow triangle in probably one transformation instead of 2. Compositions use a different form of notation. So this open circle is read as the word follows. So we would say reflect in the x-axis following a translation of 3, 4. The way we read it means we're actually going to solve it backwards. So the reflection follows. I need to perform the translation first, and then once I obtain the prime image, then I need to reflect in the x-axis. Another form of function notation can be set up as a composition as well. We're still reflecting in the x-axis and translating 3, 4. But when we read this style, we start with the innermost set of parentheses. So they want me to take point A and translate it 3 units right, 4 units up. Once I have that prime image, then I'm going to reflect it in the x-axis. So we're working our way from the inside out. One of the compositions we deal with frequently is called a glide reflection. This is a combination of a reflection and a translation that follow each other. Both parts of a glide reflection, a translation and a reflection, are both rigid motions and they're both isometries. So when you perform a glide reflection, you're also going to produce an isometry, an image that is congruent to the original. This first diagram shows triangle ABC. It looks as though it was reflected in line L, and then it was translated some number of units V to A prime, B prime, C prime. In the second image, we're starting with quadrilateral ABCD. Again, it appears as though it was reflected over line PQ to produce the prime image, and then it was translated to get the double prime image. The great thing about a glide reflection is if you don't follow the order correctly, you're still going to end up with the correct image in the end. Once you've completed several transformations and you realize that you could have gone from the original pre-image to the final location in one single transformation, allows us to rename that. In this diagram, we took triangle that's in blue. Looks like we reflected it in the y-axis, and then we reflected it in the x-axis to get its final location. But if you look at blue and then green, we could have obtained that in one step. We could have either rotated it 180 degrees, or we could have done a point reflection through the origin and got there in one step. In the second diagram, we're starting with the blue triangle. We're reflecting it over the first line, and then we're taking the red triangle and reflecting it again to produce the green image. You'll notice that the blue triangle and the green triangle are facing the same direction. So ultimately, I could have gone from blue to green with a simple slide 2 units to the right. Typically, you don't know how to rename it until you've performed all the steps and you can see where the final location is. In example 1, we're given 3 ordered pairs for our triangle ABC. The grid is optional. If you know the rules associated with translations and rotations, then don't bother graphing. So I'm going to start by listing my 3 ordered pairs. Remember, the rotation must follow the translation. So we're going to start with our translation. Translations add and subtract on the x and y coordinate. So I'm adding 0 to x, subtracting 4 from y. I'm going to bring up all the points at one time. If you want to pause the video so I don't give it away, you should do that now. So I have the rule above my mapping, my new location of A prime, B prime, and C prime. Now, since I'm performing a composition, I'm going to build off of the primes to create double primes. So now we're going to rotate 180 degrees. Rotating 180, we negate both the x and the y. So I have a location for A double prime, B double prime, and C double prime. In order to see how we could have gone from ABC to the double primes, you would have to graph it so that you can get a visual and make a determination. Sometimes one single transformation would not do it, so it's just by chance. In example 2, we have triangle ABC, and again, the grid is optional. So I'm going to choose not to graph. If you know the rule for reflecting in the line y equals x and a dilation of 2, we can just start by listing our 3 ordered pairs. When you reflect in the line y equals x, we just switch the locations of x and y. So there's my rule, A prime, B prime, and C prime. Now I'm going to dilate by a scale factor of 2, and I'm going to build off the prime images to create double prime. So dilation by scale factor of 2, this is about the origin, or they would specify some other center. So we're going to simply multiply x and y by 2. And there's A double prime, B double prime, and C double prime. I can tell you now that this composition is not an isometry. Anytime a dilation is involved, we do not preserve distance. So this would not be classified as a rigid motion. In example 3, we do have to graph, and we're going to perform 3 transformations. We're going to start with the dilation. I'm going to graph my 3 points and produce the triangle, and then list those original ordered pairs. Now we're going to dilate by a scale factor of 1/2. Again, I'm going to bring up all 3 points at one time, but we're multiplying the x and the y by 1/2. And then I'm also going to draw the new picture. So the blue triangle is the location of A prime, B prime, C prime. Working backwards, now we're going to reflect in the x-axis. So the rule here is x stays the same and y changes to its opposite. All right, here come all the double prime images. The green triangle represents the double prime triangle. And for the final transformation, I'm going to translate 2 units right and 5 units down. And all the points are going to come up at once. And the purple triangle is my final image. Could I have gotten from the red to the purple in one transformation? Maybe, maybe not. It might take a bit of investigating to find one. The final example is very much like a Regents question. We have trapezoid ABCD, which is in quadrants 1 and 2, and it becomes trapezoid double prime down here in quadrants 3 and 4. They want you to describe a sequence of transformations that will map trapezoid ABCD to its double prime location. When you go through a problem like this, you have to be very specific. If you're reflecting, tell me through what line or what axis. If you're dilating, I need to know the scale factor and the center of dilation. You must provide very specific details or else you won't receive credit. There are different options for this. The option that I'm going to choose starts with taking trapezoid ABCD and reflecting it over the y-axis. You need to pay attention. If I simply slide it down, A will match up with B double prime. I want it to match up with A double prime, so I do have to flip this over first. So my first step is to reflect the trapezoid in the y-axis. This is a very specific direction. Once it's been flipped over, I'm going to slide it down so that these two sides overlap each other. So my second step is to translate trapezoid ABCD down 6 units, and that will put them right against the same side. And once it's moved down, it just needs to flip over. So the last is to reflect again, but it's going to go over the line y equals -4, which is this line right here that will have both line segments on it. And then that should put the original trapezoid in place of the double prime trapezoid. This is homework 124. It's our first day of compositions. Make sure you follow the directions and you follow the order correctly. You can put your ordered pairs all down the side. Make sure this is a full mapping on each of these problems. When you graph, it's only the pre-image and then the final image. So it'll be pre-image and triple primes. And then they're asking you to come up with a single transformation. All 3 of these do have a single transformation that is possible. If you have any questions going through this assignment or anything on the notes, please contact me. Have a great day.